Hi, this is Sahil Pujbal, and my topic for data mining and machine learning one project is sentiment analysis using social media and music. So, in this project, I have made use of three datasets. One is from Twitter for tweet analysis, second is Spotify music database, and third is database of trending YouTube video comments. We are going to run five machine learning algorithms on this mod on this project. In this project, first is the random forest, second is naive Bayes classifier, third is support vector machine, fourth is multiple linear regression, and fifth is the decision tree. Let's head over to the code. So first is the Twitter sentiment R. We are going to load the dataset into R. We are going to make use of tidyverse library for sentiment analysis. We are going to select specifically sentiment and text as these are important columns for sentiment analysis. We are going to again include TM and the Snowball C library. They are important libraries required for NLP. We are going to make use of corpus, which is also important for text analysis, for holding texts or words or baggage of words. We are first going to just store the first text in the corpus. So this is the first text we have stored in the corpus. We are going to run all these analysis, which are to convert the text into lower, to remove numbers, punctuations, white spaces, and stem the document. So after that, we check the corpus. We can see that all the punctuations, numbers have been removed, and this is just a pure text. So we are going to create baggage of words over here with the document term matrix. We are going to inspect just the first 10 tweets for first 15 words in the data sets. So first 10 tweets and the first 15 words in the data sets, we can see the frequency, and we are going to find the frequency of which words are more frequent in the text. So we can see these are the words which are more frequent in the text with the frequencies. We are going to include the word cloud library. We are also going to see the positive word cloud for them. We are going to see the negative word cloud for them, and we are going to see the neutral word cloud. So we are going to use the convert function over here, and we are going to apply the convert function to get the final training and testing data sets. So we are going to split our data into training and testing data. We are going to check the proportion of our train and test data. For first model we are going to evaluate is the random forest. So we are going to call the random forest library. So we can check the confusion matrix of the random forest. We are going to predict the random forest right now. So using the predict function, now we are going to create random forest. We are going to check the confusion matrix. By this, we can see the accuracy of the model is 97%. We'll move to the next model, naive Bayes. With the help of our predict function, we have created a predictor variable. We are going to evaluate confusion matrix. As we can see, the accuracy of this model is 99%, which states that it's overfit. So we'll move to the next model. Our next model is the support vector machine. We can see the number of support vectors are 7389. So finally, we are going to evaluate the confusion matrix for SVM. So by this, we can see the accuracy of this model is 60% with the confidence interval, 95% confidence interval at 0.587, 0.6199. We'll move to the next data sets, that's the Spotify dataset. So in this dataset, we are going to first import our Spotify data. We're going to check this class. We're going to attach the data. We'll take a sample of 50,000 for this, as this is a very big data set, and we are going to split it to train and testing data. We are going to plot three plots over here. One will be for the valence. We are considering valence field because valence is in the range of 0 to 1, which actually signifies with a threshold of 0.5 that a value greater than 0.5 says like the song is happy or joyful, and the value if it is below 0.5 will say that the song is sad or angry feeling behind the song. So you can check the density. If we check for the log, we get a kind of value which is in between of -1 and 0. And if we go and check the plot for square root of valence, it is distributed between 0.25 to 1. It's a skewed distribution. So making a linear regression model over here, we can see over here the minimum, median, and maximum with first quartile and third quartile range values. And we can see the liveness, the variable of liveness is not that significant. So what we are going to do, we are going to rerun and remove liveness from the model. So with this, we can see all the significant values are over here, and these are the graphs for linear regression. Moving forward, we'll predict the value. We are going to evaluate a model with the help of root mean square error. So we get the value of root mean square error to 1.16 and r square to 0.39. We are going to plot our valence with the exponential of predictor 1, and we can see this kind of a scatter plot over here. Moving forward, we are going to implement our next model, that is the decision tree. So we will be needing the rpart library. We are going to fit the model. We can see the values and we can print the accuracy. Accuracy is 4.20. That is 10 raised to 8 minus 7. We'll be moving to the next data set, that is the YouTube data set. Last data set is for trending YouTube video comments. So here we are going to load all the required libraries. We are going to import our data set. We're going to make use of corpus, same as the Twitter. All these steps are for pre-processing of the data. Then we are going to get the sentiment out of the text using this function, that is get underscore in rc underscore sentiment. The only difference with the Twitter is that over here we are going to plot bar graph. So like this, we have plotted the bar graph, which tells us about the total sentiment score for all those words. Moving forward, we are going to read the data once again, and we are going to sample it with a train and test. We are going to sample and split it in training and testing data. So first we are going to run a linear regression model. As you can see, the plots for linear regression model, and we are going to predict it using the predict function. We are going to calculate the root mean square error for this model. So as you can see, the root mean square seems to be infinite, but the R2 is R2, that's the R square, is 0.76. So with this, I conclude the analysis of sentiment analysis using social media sites, that's Twitter and YouTube, and music, that's Spotify. Thank you.